Hey everyone, welcome to this week's module. So last week we were taking a look at basic views and layouts. So we talked about the fact that views were or are the base of the UI framework of the view system in Android. That is all of the visible elements used in an Android application, whether to present information or to allow interaction, are handled by views. And we spoke to the responsibilities of a view to draw itself as well as to respond to events. And we know that those events are responded to by provisioning an event listener. Every view has a set of events that they support. The view class itself, by defining a set of internal interfaces and associated events, define the core set of events that every view that directly or indirectly extends the view class will themselves implement. So that's your on click, on long click, on focus change, things like that. So every view supports those events, where we also have specific events that only some views support. And what you will find is that those views will then define the interface for their event listeners internally. So you won't find, for example, the on seek bar changed listener interface defined in the view class, because that interface and that event is specific to the seek bar. So you're going to find that interface defined in the seek bar, and that's where you would build your event listener using that interface, either through a named class, as you saw. That's a one way to do it, but oftentimes not the most practical. Through general software engineering rules and principles, there might be times when creating a named class is the best approach. But as was demonstrated, oftentimes it's sufficient to just create an anonymous class where we simply define a class, its implementation, and create an object from that class immediately and assign it to the view. Or in certain cases, we're able to use a lambda, which is an anonymous function. The creation of the class and all of that is still done, but it's just done in the background. Kotlin does that for us automatically, and we don't have to be concerned with all of the boilerplate stuff. So for simple things like onclicks, we get to use lambdas, anonymous functions, whereas for, say, the listener for the on seek bar changed event, we need to create an anonymous class slash anonymous object, simply because that has so many functions defined for it. You could not use a lambda there. Additionally, we saw, again, layouts, and the layouts come in different forms. The job of a layout is to allow us to arrange the views in a specific type of container, so like a Windows or an activity, which is the technical term. And there are other places where you get to use layouts to present views. Not stuff we're going to touch in this course, but just for completeness, places like notifications can use views and layouts, as can widgets, which are these little miniature programs that can run basically embedded in the device's home screen. So think of seeing like a clock or a calendar built into the desktop or the home screen of your phone or tablet. That's a widget. So layouts have different rules. Each layout will have its own set of rules governing how child views are laid out. A layout is itself a view. Technically, the layout extends the view class, again, directly or indirectly. In the case of layouts, it's always indirectly. And that they extend the view group class, and the view group class is what allows them to contain other views. So a layout is a view that contains other views. By and large, the layouts themselves are invisible. They are just top level containers that within which you store the actual views that the user sees and interacts with. The constraint layout is the the one layout to rule them all. That was a late addition to the Android SDK. That, well, technically not a part of the SDK officially. It's a separate library. It's just added automatically when you create a new app. And that was designed to allow us to create very powerful and expressive layouts without having to have a deep hierarchy or a deep tree where we have nested layouts in layouts in layouts. The constraint layout's job or its goal is to allow us to create flat hierarchies where it's just the layout and then all the views are one layer deep. And we use constraints to specify how these layouts how the child views should present themselves or be arranged inside of the constraint layout. Okay, so that's it is for a recap. So what we're going to look at this week is a continuation of our look at views, but instead of looking at just the basic views that we saw the last time, which is our buttons, our text views, we're going to look at a special type of view called an adapter view. And what makes an adapter view interesting is that unlike prior views that we've seen where everything about the view, how the view looks, is defined via its attributes, which we could set at design time, that is where we're building the interface and we have the little window and we fill in values, or at runtime where we could change the properties. So changing the text property of a text view, for example, will change the text that is being displayed. But ultimately, whatever we assign to an attribute determines how the view looks. In the case of adapter views, an adapter view is really just itself a container, which is able to display other views, other child views. And what's interesting is that the adapter view or the adapter views, we really just focus on one type that's called a spinner, which you might interpret as a drop-down selection box in other paradigms in web or desktop development platforms. The spinner is provisioned with child views to display via a separate component that is given to it called an adapter. So the adapter is sort of a view generator. These components work in tandem, which essentially means you don't know what the spinner or any other adapter view will look like at design time. It's only when the program is running and it's given the child views via the adapter that it can then display. So unlike other views in the past where you could always see what it looks like as you're designing it, with adapter views, you don't know what the view is going to actually display until the program is running. So that's kind of interesting. And there are a few more pieces to that puzzle. There's the data that the adapter uses to generate the views. There is we still have this notion of an event listener. So the adapter is what is used for the view uses that to draw itself. But we still need the event listener because the user can interact. So you're going to see, in the case of the spinner, you're going to see the on item selected listener, things of that nature. So that's pretty much what we're going to look at this week. We're going to look at basic adapter views, and then we're going to transition into custom adapters where we can create more complex views that get displayed by the adapter view. And that is, of course, useful where you want to display something that is outside the basic prepackaged adapters that are provided for you. So if you want to have your views take on a particular view, a particular look, you can create a custom view, a custom adapter rather, to generate those views. So additionally, you're also going to have your first assignment, and with your assignments, you're going to utilize a concept that we were introduced to early in the semester called version control. We're going to use a version control or version management system. One of the technical terms is source code management or source code management system, but collectively the tools are called VCS, which is a version control system. So sometimes I get my terms confused. Specifically, we're going to use Git, and the service provider we're going to rely on is GitHub. So in order for you to engage in and submit your assignment, you're going to create and make sure that you have a GitHub account. So you may want to go back and review the Git videos if you'd like a refresher. And thereafter, you're going to complete your assignments by sharing your project or making sure your project is on GitHub, and you're going to go through a series of commits as you do your work. A commit is just, you can think of a commit as a checkpoint along the way as you're coding, and then you submit or push your project to GitHub, and then you will submit the link for your repository or just to the web page to Canvas. So it's a few steps, pretty relatively straightforward. You'll get the details of what you need to do and check off in the project description, the specifications. But insofar as you're going to be committing your work, it really is just a series of commits and then finally a push. So here, as an example, I'm using the old interface here, but again, your new interface, the newer UI is going to have a similar layout. Maybe I'll look at that afterwards. But ultimately, what it boils down to is you're going to do a series of steps before you begin your assignment, which is going to give you a copy of a base assignment to work with. So that's the first thing. You're going to get a base assignment. So you're going to install Git on your computers. Then once you have Git installed, Android Studio will be able to use Git, and you'll get to do things like have or clone a project onto your machine. This project is one I've just picked up or I previously had. So I'm going to just to show you the committing steps. I'm going to put this project on GitHub. So I'm clicking VCS, share project on GitHub. And this is giving me, just to make sure that you can see the little window that pops up. So I have a little window here that allows me to type in a message. Sorry, not a message, the name of the repository. So this is my test app. I can put a description, etc. Then I can share. It asks me to make an initial commit. Again, some of this might look familiar from the original videos you saw. I hit add. And then I'll get a little message here telling me that it shared successfully, as long as we, in fact, did share successfully. Now, once we have this project on GitHub and we have a repository locally, which is what I did when I created share project on GitHub, I created a local repository, and a GitHub repository was also created, which serves as the remote or the origin. It's kind of like the base for my project, and I just have a copy on my local machine. Then whenever I do something, I can commit that change and then ultimately push. So let us say I am completing this project, whatever this is. I want to declare some properties. So let's say I go and I take a look at my layout file. And my layout file has, oh, I don't want to wait on it. Okay, so I have a text view. Maybe this text view is something I want to use, so display text view. I have a edit text called name edit text, and I have a button called click me button. So I may want to store those references. So I'll create some references for those. It was name edit text. And then there was also one for click me button, which was a button. So I've added that code, and maybe I want to initialize those elements. So name edit text is equal to find view by ID r.id dot name edit text, and click me button is equal to find view by ID r.id dot click me button. So at this point, I've set up or wired up my activity to my layout, and maybe I want to now lock this code in. So I want to make a checkpoint here. So what I would do is I would go to Git. The VCS menu option has now been replaced by Git, and I will specify that I want to commit. So that is the first menu option Make sure that you can see it. So Git, I now select commit. And this is asking me, okay, well, what are you committing? Okay, well, I want to, it selects the file that was changed automatically. I don't have to do anything as long as I'm using all of my, I'm doing all of the source code management inside of an Android Studio. I usually don't have to check any boxes. It'll all just be automatically done for me. So here I will say referenced all layout views in activity. So I'm describing the job I just did. And so at this point I'd commit if I want to keep working, or I could commit and push, which will lock in, but also send the change to GitHub. So I'm going to do that here just so we can see. So I commit and push, it tells me, okay, we've made the commit. Here's the message associated with the changes I just made to my source code. I now hit push, and my project is now sent to GitHub. See, it's pushed one commit to origin master. And I'll keep doing that. If I add new changes, I'd make another commit, and I would push that change. And eventually, when I'm finished, and I've made my last commit and my last push, I'll take the URL from GitHub. Again, that's the URL that you will see that project created for you automatically when we go through the steps and the specifications. I'll take that URL and I'll submit it to Canvas. In fact, there's a shortcut here, which is instead of having to go through all the steps of coding and then submitting to Canvas, because of the way we're going to use Git, we're going to use something called GitHub Classroom, which is going to create a repository for your project automatically. The beauty of it here is that all you really need to do is once you get that URL, you can submit it to Canvas immediately. You don't even have to wait until you're done coding. All you'll be doing there is telling me how to get to your project when it's finished. So just to make sure that we don't forget, or the deadline passes and we forgot to submit the URL, when you go to GitHub Classroom and you generate your project, you'll see the buttons and everything to do that. Once you generate your project, you can just submit that link immediately to Canvas. Unfortunately, GitHub Classroom and Canvas are not integrated. It would be really nice if they were, and we could just have that step done automatically, but it's not. So we have to kind of do that manually. Again, I'll give you the instructions, and just know that you can submit the URL at any time. You don't have to finish working on your project first. So I've just showed you the general flow of how GitHub can be integrated with a project. But again, know that when you are doing it, when you're doing an assignment, you'll actually be given a starting project. So that starting project can actually be initialized a little differently. So what you will basically have in that scenario is the ability to, from this wizard, you'll click on Get from VCS. And once you hit Get from VCS, you'll see here a few options: repository URL, GitHub, or GitHub Enterprise. Once you have installed Git on your machine and you've set up your GitHub password or GitHub account with a password, all you need to do to clone a project, to get a project local on your machine, is to select GitHub here, and then you will see all of your projects listed. And so, for example, notice the project I just saved called Test App. Here I can see it because this is on GitHub. So I can now select Test App and hit clone. Now, if I hit clone, it won't work for me. Oh, it does work for me. Never mind. I was going to say that I already had a project called Test App, but in reality, it was called something different on my machine. So that's why I was able to clone it. So I was able to simply download the project. See that again. It's just Get from VCS, GitHub, and then you type the project repository name that you're looking for. So maybe it's assignment 1 or assignment 9 or whatever. You just type it in and you'll see it here. Okay, now if I try to clone it, it'll tell me the project already exists. So I could change the directory here. or I could delete this project if I don't want it anymore and reclone it to get a new fresh copy of the project. So this is how you're going to get your assignments. You're going to you're going to follow a link. You're going to create an instance of your project or a copy of what's called, the technical term is a fork. That fork is going to be placed in your GitHub, and then you can simply open Android Studio and search for it. Before any of this can happen, you will have to do a one-time login. So it'll tell you to log into GitHub. I'm already logged in, so that is why I didn't have to do that step. But once you link your GitHub to your Android Studio to GitHub, then you can just do a search for your project here. Click clone, it'll open the project and you can begin working. All right, so that's the biggest change that we are going to have, the biggest new thing. It's as we work through our projects, we're going to be using this version control system. So I would like you to, for this first assignment, I'd like you to start early because we want to make sure that we can work out any of the kinks in GitHub so that going forward, we don't run into any problems. And I think maybe the last thing I'll do even before we finish there is I'll just enable the new UI so you can see how some of this changes or how it looks a little different. So here, I'm going to go to settings and I have here new UI. So I'm going to enable it. It's going to do a restart. Hopefully it'll be quick, just so you can see the new UI and I can show you where you will click for any of these features you're trying to implement. So they've actually put it right at the top. For a new project, you'll see this, you'll see version control right in the top left. But because this project already has Git enabled, it just shows master, which is my current branch. But a new project would just have version control here instead of VCS, and I can click that to get access to all of my VCS or my version control features. So this is the new UI, which you would probably have if you just installed Android Studio. If you did not just install, or you installed it but you still got the old UI and you want to get the new UI, then it's just a matter of going to the settings and enabling it. All right, so that's pretty much it. If you have any questions or concerns, just send me an email or come to office hours. Again, try starting on the assignment early just to get through, work out the kinks with Git if we have any. And then if anything, we can always meet during office hours or some more convenient time. All right, thanks everyone and good luck.